Hello students, welcome back to the lecture number 28 of chapter 7. Right. So in this lecture we will solve the question number 1 and 2 from the exercise 7.4. So let us start with the first question. So here is the first question which gives that so that in a right angled triangle the hypotenuse is the longest side. So what does it mean? Okay, it gives that you have to prove that in a right angled triangle. Let's say this is a right angle triangle. Right angle triangle means a triangle in which any one angle is 90 degree. Let's say this vertex angle is 90 degree. So in a right angle triangle, the hypotenuse is the longest side. First of all, we have to identify out of the three sides AB, BC and AC, which side is the hypotenuse? Tell me, how can we find the hypotenuse? I have told you. In order to find the hypotenuse, you have to find the side which is opposite to the 90 degree. Since this side is opposite to 90 degree, hence AC is known as hypotenuse. Right? And here we have to prove that AC is the longest side. That means AC must be greater than this side. And SC must be greater than this side. We have to prove it. Okay? So let us prove it. We know it that yes, hypotenuse is the larger or longer side, but we have to prove it how it is possible. Let's see. So in the given, what is given here? It is given that ABC is a right angled triangle with angle B is 90. This is given. And SC is the hypotenuse. SC is the hypotenuse. So what to prove? What to prove? To prove SC is the longest side. It means we have to prove SC is greater than this side and that SC is greater than this side. This is the ultimate meaning of SC is the longest side. Out of the three sides, SC is the longest side. Okay. So let us prove it. Okay. Let us first understand. So as we know, in a right angle triangle, this angle is 90 degree. Then tell me, these two angles are added to give how much? If this angle is 90 degree, then these two angles are added to give how much? We know in a triangle, all the three angles are added to give 180 degree. Then if this angle is 90 degree, then this angle and this angle are added to give what? 90 degree. Because 90 plus 90 is 180. That is why this angle and this angle must add to give 90 degree. Okay. So either if you take this angle as 60 degree, then what is the value of this angle? Must be 30 degree. If I take this angle as 45 degree, then what is the value of this angle? Must be 45 degree, because 45 plus 45 is 90 degree. If I take this angle as 20 degree, then definitely this angle is 70 degree. Isn't it? Yes. So if this angle is 90 degree, then definitely these two angles are added to give 90 degree. Then there is a conclusion arises. What is the conclusion? The conclusion is that, can we say this angle is greater than this angle? Is it possible? Tell me, is it possible? Can this angle is greater than this angle? Yes, definitely it is possible. Why? Because if we take this angle greater than B angle, if we take angle A greater than B angle, then what is the sum of these two angles? Tell me. Is 181 degree. But we know the sum of all the three angles is 180 degree, but it is greater than 180 degree. Is it possible? No, it is not possible. It means the angle A must be less than angle B, right? It means it is either you can take 89, 88, 70, 40, but it definitely less than 90 degree. So between this angle and this angle, which angle must be greater than this angle? So B must be greater than among the A and B. You understood? So simply we can write that angle B is greater than which angle? Angle A. Right? Now, similarly, the value of this angle can never be greater than 90 degree. Why? Because if we take this angle as 90, suppose 91, 92 degree, then sum of 90 and 92 is 182 degree. But we know for a triangle the sum of the three angles is 180 degree. Definitely it is greater than 180 degree, so it is not possible. So it shows that the value of angle C can never be greater than 90 degree. No, it is not possible. So the value of C angle must be less than angle B. Understood? So among the angle B and C, which angle is greater? This angle is greater. Okay? So simply we can write and angle B is greater than angle C. Okay? Now remind the theorem number 7.7. According to theorem 7.7, we know if in a triangle, right, two angles are unequal, then the opposite side of the longer or larger angle is longer. Okay. Here, since we know the angle B is greater than angle A, right? And what is the opposite angle of angle B? That is AC. And what is the opposite angle of angle A? This one, that is BC. So according to the theorem 7.7, this angle is larger than this angle. So the opposite side of this angle, that is AC, must be greater than this BC. Clear? Similarly, here we get angle B is greater than angle C. So according to theorem 7.7, the opposite side of angle B, that is AC, is greater than the opposite side of the smaller angle, that is angle C. That means AB. Understood? So these are the two conclusions that we can draw from the theorem number 7.7. It is clear now? Now. So what we have got? We have got SC is greater than AB here and SC is greater than BC. So tell me, this is greater than this greater than this. So among these three sides AB, BC, SC, which one is the largest side? Which one? Definitely SC is the largest side. Implies this from this and this two equation, what do we get? SC is the larger side. Understood? And we know SC is known as hypotenuse. So hypotenuse, you can write larger, not larger, you can write largest. Largest means it is the biggest in length among the three sides. Okay? And you know SC is the hypotenuse, so simply you can write hence hypotenuse is the longest side. Okay, this is now proved. Okay. Next, coming to the question number 2. In question number 2, it is given in triangle ABC. So let us first draw a triangle. As soon as you read the question, you have to draw a figure. Okay. So in triangle ABC, AP and SC sides of triangle ABC are extended to a points P and Q. That means two sides AB and SC are extended. That means they are produced like this. Okay. So they are produced like this. Similarly, the side SC is also produced like this. Okay. It is produced to a point P and SC side is produced to a point Q. Understood? And angle PBC, which angle? PBC. That means this angle. So this is the external angle of the triangle ABC. Each less than, this is the symbol of less than, right? QCB. QCB. So this is also an exterior angle of the triangle ABC. This is given. Now from this data we have to prove that SC side, this side is greater than AB side, this side. We have to prove this. Okay. So let us first write what is given. So it is given what? PBC and QCB are two exterior angle, right? Are two exterior angle of triangle AB, and it is given that this angle is less than this angle. Or you can say, yes, this is the greater angle than this angle, right? So simply you can write QCB angle is greater than PBC. Okay. This is the smaller angle and this is the larger angle. That is why I write it alternatively. This is the larger angle which is greater than this angle, right? Now, to prove AC side, this side is greater than AB side, this side. How can you prove it? This is very interesting. See, if we consider ABC as a triangle, for triangle ABC, okay, this angle is an exterior angle. QCB is exterior. Okay, so you can write, what you can write? QCB angle is exterior. And just recently we have discussed in the example number 9, lecture number, I think it is 26, right? 26 after 27. We have discussed that in a triangle, right, the exterior angle is always greater than its interior opposite angle. How? Let's understand it. If this is the exterior angle, then we know the exterior angle is the sum of two interior opposite angle, right? If it is take 5, then definitely 3 plus 2 are added to give 5. So this part is definitely greater than this part. This part is definitely greater than this part. Similarly, these two are added to give the exterior angle. That means this is the larger one. So this must be greater than 1. And this must be greater than 2. Okay. So simply we can write here, this is the exterior angle. Then what are the two interior opposite angle of this exterior angle? Definitely this angle and this angle. Now can we write this angle is greater than this angle? Yes. Can we write this angle is greater than this angle? Yes. So let us write it. So simply we can write the angle QCB, okay, is greater than which angle? Is greater than this angle B, or you can write ABC angle. Okay, done. Either you can write this angle or you can write this angle, but for my convenience, for the requirement of the question, I have to take this angle. And you know the reason why I have taken this angle, because if we take this angle B, then its opposite side is AC, and we need a term AC in the proof section. That is why I have taken this angle. Okay, so this is equation number 1. Okay, then for triangle ABC, again, this is also an exterior angle. Yes or no? Yes, this is also an exterior angle. So angle PBC is exterior. Okay, let us make it in a box. So similarly here also this angle is equal to sum of two interior opposite angle. So for this angle, two interior opposite angles are this angle and this angle. That means this angle must be greater than this angle and this angle must be greater than this angle. So for the requirement of the question, I have to take this angle is greater than this angle. Okay. So right implies angle PBC is greater than this angle ACB. Equation 2. Okay. And now since already we know QCB angle, that means QCB, this angle is greater than PBC angle, PBC. So write it, since QCB angle is greater than this is PBC angle. This is given. Okay. Now let us conclude a statement here. Okay, for this I have to give you an example. Okay, let's understand it clearly. Since it is given QCB angle is greater than PBC angle, let's say for our understanding, let's say QCB is 10. Okay, let's say PBC is 6. Okay, so 10 is definitely greater than 6. You understand it? Next, from the equation we know that QCB means what we have taken? We have taken 10. In the equation we know that QCB, that means 10, is greater than ABC. ABC. The value of ABC is not given. Let's say ABC is 7. Done. In the equation number 2 it is given PBC. What is PBC? We have taken 6. Right. So 6 is greater than ACB. ACB. So we have to take the value of ACB such that it is less than 6. Definitely is less than 6. Let's say I choose 4. Do you understand these three terms? 10 is greater than 6. We know. From the equation 1, 10 is greater than 7. We know. From the equation 2, 6 is greater than 4. We know. Okay. Then can we write this one is greater than this one? Can we write this? Tell me. This part is greater than this part. Can we write this? Definitely we can write this. See this. 10 is greater than 7. But 6 is greater than 4. That means here 7 is greater than 4. We can write it or not write it. Yes, we can write it. Because 10 is greater than 6. But 10 is greater than 7. Okay. And 6 also greater than 4. That means these two parts, what is the relationship between these two parts? Here this part. That means this part is greater than this part. Is greater than this part. That's why I have to take an example. So that you can simply write it that this angle, which angle? Angle ABC is greater than this angle. Angle AC. Okay, do not write it in the examination hall. No. This is for your understanding. Okay, so finally we have proved that ABC angle, this angle is greater than SCB angle. Is greater than SCB angle. Okay. Now, remember the theorem number 7.7. According to theorem 7.7, we know if in a triangle any two angles value are different or unequal, then the opposite side of the larger angle is longer. So, in between these two angles, which angle is greater? Definitely angle ABC. ABC means what? ABC means what? Angle B. SB means what? Angle C. So, definitely angle B is greater than angle C. What is the opposite side of angle B? AC. SC. And what is the opposite side of angle C? AB. So definitely, according to theorem 7.7, the opposite side of the larger angle is larger. So SC is greater than AB. Okay. And finally, we have proved it. Here we have to prove this statement, and we have proved it. And it is now proved. See, it is very easy and very interesting to prove. You have to understand the concept. Okay. What I have given as an example. If this is greater than this is greater than this greater than this, then definitely this is greater than this. Okay, so this is the proof of this question number 2 from the exercise 7.7.